Hello everyone, my name is Claudia Amador and this is a video for a project that I have for my history of math class. This is the oral presentation. I selected the problem that says to solve the given linear diophantine equation. Part A says 12x plus 9y equals 15. And part B says ax plus 10y equals 17. So I'm going to explain detail by detail how to do either part A and part B. So on part A, we have the equation that 12x plus 9y equals to 15. So the first thing that we have to do in order to resolve this equation is to find the GCD between 12 and 9. So this is what I'm going to do right now. I'm going to let D equals the GCD of A comma B. So D equals the GCD of 12,9. Okay. So now in order for me to find the GCD between 12 and 9, I'm going to be using the Euclidean algorithm to find the greatest common divisor between these two numbers. So by using the Euclidean algorithm, we get the GCD between 12 and 9. So we can start by getting the 12, and we say that 12 is equal to 9 times 1 plus 3. Then we get the 9 down, and 9 is equal to, we get the 3 down again, 3 times 3 plus 0 equals 9. So we can say that 3 is the GCD, the greatest common divisor between 12 and 9. Now that we have the GCD, that is 3, we have to see if the GCD divides this number on the right-hand side of the equation. And we see that yes, that 3 divides 15. So we can conclude that the given equation has a solution, so it's solvable. So the GCD between 12,9 is equal to 3, which divides 15. Therefore, the given equation 12x plus 9y equals 15 is solvable. So now we have to find a particular solution for this equation. First of all, we have to observe that 12 times which number give us the GCD. So if we see 12 times 1 plus 9 times negative 1 give us 3, which is the GCD that we already found. Consequently, which number we can multiply by 12 that give us the GCD, then when we multiply another number, give us the right-hand side result of the equation. So in this case, 12 times 5 plus 9 times negative 5 is equal to 3, which is the GCD, times 5, which equals 15, which is the number on the right-hand side of the equation. And we see that the x of 0, comma y of 0, so the particular solution for this equation is 5, comma negative 5, because we found it by doing this this game with the numbers. Okay, so now that we have the particular solution, we are going to find the general solution for the equation. So how do we find the general solution for the equation? We have a formula that it says that x is equal to x of 0 plus b over d times t. So x of 0 is the general solution for the value of x. Then the b is the value of the y, which is 9. And d, as we put here on the beginning, is the GCD between a and b. So we get, when we substitute back on the equation, we get that x is equal to 5 plus 9 over 3 times t. When you do the division, we get that x is equal to 5 plus 3t. Now we're going to do the same thing but for y. Just have in mind that in here the equation changed a little bit. Instead of being addition, it's going to be subtraction. So we get that y is equal to y of 0 minus a over d times t. So if we do the same procedure and we substitute back the numbers into the equation, we get that the general solution for y is -5, right here, minus 12, which is the value of the x, divided by the GCD between 12 and 9, which is 3. We get that the equation is equal to y equals to -5 minus 4t, where t is an integer. And in this equation, we got that the general solutions, we got both the general solution for x and for y. And we arrive to the conclusion that the equation is solvable. Okay, so now we're going to do the same steps and the same procedure for part B. So part B is the equation ax plus 10y equals 17. We're going to do exactly the same thing as we do on the previous example. We're going to let d equals to the GCD between a and b, where d is equal to the GCD between 10 and a, which are the values of our equation. So now we're going to use the Euclidean algorithm to find the GCD between 10 and a. By doing that, we get that 10 is equal to a times 1 plus 2. We get down the a is equal to 2 times 4 plus 0, and we can conclude that the GCD between 10 and a is equal to 2. But in here, we have to check if 2 can divide 17. In this case, we see that 2 cannot divide 17. Therefore, when we get into this situation where the GCD cannot divide the right-hand side of the equation, we can get to the conclusion that the equation has no solution, so it's not solvable. So we can definitely conclude saying that therefore ax plus 10y equals 17 has no solution because 2 cannot divide 17. So in this video, we saw two examples that is a diophantine equation where one has solution and the other one has not solution. If we go back to the example, if we go back to the previous example, we saw that the first thing that we had to do was to find the GCD between the two numbers. If the GCD divides the right-hand side of the equation, then the equation is solvable. We find the particular solution, and then we find the general solution by using these two formulas. On the other hand, we saw another example that it had no solution because the GCD of the two numbers cannot divide the right-hand side of the equation. Therefore, we can conclude that the equation is not solvable. So this is all for now. I hope this video helps, and thank you very much for watching. Bye-bye.